Alright, so in today's class, I mean, this F statistic we have that follows F distribution with parameters p plus 1 minus k and n minus p minus 1. So that's the general theory. The general theory to test between a reduced model, so H0 is reduced model, HA is full model. If you want to do that test, if you want to see if reduced model is true or not, you do the following F test. So that's the theory, that's the general theory. And how you use it? You use it as if F is big, then you reject H0. By big, you mean how much big? It's bigger than this number, the number above which there's alpha probability, below which there is 1 minus alpha probability. And this number is like has this particular notation in the textbook and elsewhere. We also learned that F, which is originally given by this formula, can also be given by this formula. And this particular formula is sometimes, I think I have seen more use of the second formula than the original formula. So this we learned and we applied this. So for example, for the cigarette sales data, if we look at this summary, we see that only income and price have very small p-value. That means they are significant. So what would happen if we say that the reduced model is only sales follows income plus price? That means we are dropping all the other variables. So let that be fit 2. So from fit and fit 2, we get the R square for both. And we use the formula to get the F statistic as 1.141784. And we compare that to the 3 cutoff points. So the cutoff point for 0.01 is 3.77, for 0.05 is 2.58, and for 0.1 it's 2.077. If we compare to any of those three, we see that our F statistic is small. That means we should not reject H0. That kind of means that the reduced model is good. We can, it's okay if we drop the other variables and just keep income and price. And we did all this with our hands, but the way to avoid all these calculations by hand is just by doing ANOVA, reduced model, full model. That will give us a table output like this. It has a lot of stuff, but you just look at the last two, F and the p-value. So the F is 1.14, the same thing as us, and the p-value is this. Now the p-value is high. P-value high means good for H0. That means we are keeping the reduced model. So that's just another way of doing the same thing, but it's less, you have to do less, that's all. Next, we did another application of the general theory. The application was testing the validity of all variables. That means, what if our H0 is all the variables are useless? So our reduced model, or our H0, is all the variables are useless. Once again, the F statistic for that particular case is given by this particular formula, R square by P whole divided by 1 minus R square by N minus P minus 1, which follows F with degrees of freedom P, N minus P minus 1. And you do the same kinds of things. You find out the cutoff and but you don't have to do that. You don't have to calculate this F on your own. It's usually such important thing that it's already given. So when you do summary fit, it's already given to you at the bottom. And the p-value is also given to you. And for this particular case, we see the p-value is small. That means that's not good for H0. So that means we are rejecting the idea that all variables are useless. That means some variables are definitely useful. I mean, as we know that income and price are useful. Next, we start with a new example.